So 4.2, graph linear equations. So to start out with, a solution of an equation in two variables and for the sake of what we're doing, there'll be x and y, is an ordered pair xy that produces a true statement when the values of x and y are substituted into the equation. So some of what we'll be doing is like plugging in a coordinate, an xy coordinate, and deciding if it makes the statement true or not. So we'll be saying if it's a solution or not a solution. And then we'll obviously be graphing as well. And then the graph of an equation in two variables is the set of points in a coordinate plane that represent all solutions of the equation. So the stuff that we did back in 3.8 where we were solving equations for y is going to be a lot of what we're doing here going forward. The steps to... Now, I will tell you, there's going to be many different ways in which we can graph a line, okay? Each section in this chapter, at least for the next 3 sections specifically, have different methods to use to graph the line. And so if it specifies which method you have to use, make sure you use that method. If it just says graph, you'll be allowed to pick whatever method you want. So, let's see. So steps to graphing an equation as how we would do it in this section. We will first solve the equation for y. AKA get y by itself. Then 2, we make a table by choosing a few values for x and finding what y equals. For each x value. I'm going to say that there's a minimum requirement of 3 points that get graphed. Then the next step is that we plot the points. So the table will produce an XY value for you. So we plot the points, and then lastly we connect the points by drawing a straight line through them. And I have plenty of rulers, so I'm not like one that's like, you have to use a ruler with it to make it like perfectly straight, but if you want that to be able to connect your dots just to make it look nice, you can absolutely use one. I have plenty up here. If your points don't make a straight line, that's your clue that something's wrong. So the standard form equation of the line. This will be more important in the next section that we do. They'll have to be in this form, but I just wanted you to go ahead and see it. But it's in the form AX plus BY is equal to C. So X and Y are the variables. A, B, and C are just going to be numbers. They can be any number. They just can't both be 0. We can also have equations of horizontal and vertical lines. So we have two options. So the first one, the graph of y is equal to b. So if you have your y your y variable is equal to some number, it is a horizontal line. The line passes through the point 0b. And that would look something like this. You have a point here on the graph that is the point 0b. A horizontal line goes like this through it. And the arrows just indicate that it's continuing on. But this would be the graph of y is equal to b. Then the other one, the graph of x is equal to a, is a vertical line. The line passes through the point A0. And so it would look something like this. This point is A0. It would be a straight up and down line through it, and that equation would be x is equal to a. So So if you end up with x is equal to something, your point is on the x-axis. If you have y is equal to something, it's on the y-axis. I should say if it's equal to just some number, it's on the axis. And it's either a straight up and down line for x equals or a laying down line for y. All right, the next thing I'm going to write, and it might be confusing right now. It's more something you'll need to know in the future in math, not so much right now, but it's good to go ahead and see it. If the domain, which are your x values, of a linear function is not specified, it is understood to be all real numbers. So basically, what that's saying is if it doesn't specify, the line is going to go on forever in both directions. Is essentially what that means. All right, so on to some examples. Tell whether the ordered pair is the solution of the equation. So these ones, they give you an equation, like in this case, 3x minus 2y is equal to -5. And then they give you an ordered pair. In this case, it's -1, 1. And so we're going to plug that in, and we're going to see if the left side is equal to the right side. So we don't even have to touch the right side in this particular problem. We just want to see if when we plug that in, if the left side equals -5. So -1 is our x value, +1 is our y value. And so we just replace x and y with those values. So we would have 3 times -1 minus 2 times y is 1. And in theory, it should be equal to -5. If it's a solution, I should say. So 3 times -1 is -3. -2 times 1 is -2. So that's -5 is equal to -5. And I just put a check mark to show that it's a solution, is what I usually do. And if it's not a solution, I'll usually just put an X. Your book will write solution or no solution. But. And then number 6, y is equal to -7. And we're given the point -7, 0. So, again, x is -7, y is 0. There's no x value, so if one of the variables is missing, you just don't plug that one in. It just, ignore it, it's gone. So I replace y with 0, so 0 is equal to -7. Well, obviously that's not true. So I just put an X to indicate no solution, or not a solution. let's see, 8 negative 5y minus 6x is equal to 0. And the point they give is negative 6, 5. So what do I do here? I'll let y'all tell me this time. Or what? Let's start out with which one of these is x and which one's y?
Negative 6 is x.
Yep.
5 is y.
Yep. So then now what?
Negative 6 times negative 6.
I need this part too.
5 times negative 5.
So then negative 5 times 5 is what?
Negative 25.
Negative 25, and then negative 6 times negative 6 is?
Negative 36.
36, so then 36 minus 25 would be what?
11.
11 equal to 0. Obviously that's not true, so it's not a solution. Any questions about checking to see if it's a solution or not? I know we've done stuff similar to this before, you know, checking to see if something's a solution. It's just now we're plugging in 2 values instead of just 1. All right, so we're on to graphing. I'm going to tell you this is my least favorite method of which to graph. I don't think it's the easiest method. So I was like, okay, well, I guess we're going to start out with that first. It's a foolproof method. It will always work, but there are easier methods in my opinion. But it's what this section is, so that's how we're going to do it. So number 12, y minus 2x is equal to 5. So the very first thing I need to do, step 1, is that I need to get y by itself. So how would I go about doing that?
You would add 2x.
I'm going to add 2x to both sides. So y is equal to 2x plus 5. Then step 2 said to make a table. Minimum of 3 values in the table. What just happened? So I do an XY table like this. And then I like to pick easy numbers to plug in. So I like to pick stuff like -1, 0, and 1, personally. They're the easiest values to work with. So for -1 first, I plug in -1 for x and I see what y equals. So y equals 2 times -1 plus 5. So y equals 2 times -1 is -2 plus 5. So y is equal to 3. So this is when x is -1, y is 3. So the point that I'm going to graph, I like to go ahead and write it down at the bottom, is -1, 3. When I plug 0 in, if y is equal to 2 times 0 plus 5, well, 2 times 0 is 0, so I just have that y is equal to 5. So when x is 0, y is 5. So I'll go ahead and write that in. So that's the point 0, 5. And then lastly, I'll do it for 1. So y is equal to 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7, so y is equal to 7. So then I have the point 1, 7. And then I'm going to see if I can switch this over to my little graph paper. So I'm going to set up a graph so that I can graph these points on it. So I just graph them in order. So -1, 3. So back 1, up 3. 0, 5. So I stay on the y-axis and go up to 5. And then I have the point 1, 7. So I go right 1, up 7. And then I just connect my dots. It's not going to do it nicely for me, so I'm just going to have to do it. But as good as, close of a line as you can, unless you want a ruler. And so again, we put the arrows on the end just to show that it keeps going in both directions. Any questions about that one before we do some more? Kind of makes sense. Let's see. Let's look at 14 next. Now 14, y plus 4x is equal to 1. So what do I need to do first here?
4x on both sides.
So subtract 4x on both sides. So y is equal to -4x plus 1. And then what is my next step?
The table.
Table. So I'm going to do x and y values. So again, I'm going to use -1, 0, and 1. So y is equal to -4 times -1 plus 1. -4 times -1 is
4.
4 plus 1 is
5.
5. So y equals 5. So I put in 5 here. And that gives me the xy point, -1, 5. Then I'm going to plug in 0. So y equals -4 times 0 plus 1. -4 times 0 is
0.
plus 1.
1.
So y equals 1. So that gives me the xy point, 0, 1. And then I'm going to plug in 1. So y equals -4 times 1 plus 1. -4 times 1 is
-4.
plus 1.
5. -5.
Nope.
-3.
-3.
Oh.
Yep, -4 plus 1 would be -3. So then that gives us the point 1, -3. So now we can set up a graph to graph those. So we have the point -1, 5. So back 1, up 5. Oh, I almost left room for it to fit. Then I have the point 0, 1. So stay at 0, go up to 1. And then the point 1, -3. So right 1, down 3. And then you can just connect the dots. That one kind of worked. Any questions about that one? All right. I'm going to do 15, which I know is an odd one, but I want to show you something because the other ones, I would never tell you to do this way. I would have you use a different method, so there's no point. I mean, I just don't see a point in confusing you with it. So I'm going to show you one that's a little bit harder and what we would do in that situation, but other than this one, like, you wouldn't have to do one like it. So one similar to it. So 2y minus 6x is equal to 10. So what do I need to do to get y by itself?
Add 6x.
Yep, add 6x. So 2y is equal to 6x plus 10. And then now what? Oh, it burned out. Divide by 2 from everything. So that's y is equal to 6 divided by 2 is 3. So 3x plus 10 divided by 2 is 5. So this is the equation I'm going to use, 3x plus 5. So the reason that I said I wouldn't have you do the other kind is that basically when you have to divide this, they weren't coming out to be even and it had fractions. And I wouldn't have you plugging in numbers to something with fractions because it's just going to, you know, they're weird. There's a better way to do those type of problems in terms of graphing, so that's why I'm not going to do those ones. If it doesn't divide out evenly between the numbers, I won't give you one like that. So my table, so -1, 0, and 1. So plug it in. Y equals 3 times -1 plus 5. 3 times -1 is -3 plus 5 is, or 5 minus 3 is 2. So y equals 2. And so that gives me the point -1, 2. Then if I plug in 0, y is equal to 3 times 0 plus 5. 3 times 0 is
0.
plus 5.
5.
So y equals 5. So that gives me the point 0, 5. And lastly for 1, y equals 3 times 1 plus 5. 3 times 1 is
3.
plus 5 is
8.
8. So that gives me the point 1, 8. So plot the points, -1, 2, so left one up to 0, 5, so you should go up the y-axis to 5. And 1, 8, so go right one, up 8. And connect the dots. All right, and then the last graphs here that we're going to do, number 20 is y equals 0. So this one, we don't have to make a table, okay? What type of line did we say it is if it's just y equals a number? Is it vertical or horizontal? You can look back at your notes if you need to. Horizontal, okay? So we set up our graph. And y equals 0 right here. It's horizontal, so we literally just draw the line on top of the axis, and that's y equals 0. If it was x equals 0, it would just be up and down on the y-axis then. So it'd be a vertical line. And on the note of x, let's do this one. So 22, x is equal to 2. So again, you don't need to do a table. So if y was horizontal, x is vertical. So we just set up a graph. And these graphs don't have to be anything big or crazy. So we go over to 2 on the x-axis. We plot a point, and we just draw a line through it. And that's the graph of x is equal to 2. So those ones are hands down the easiest graphs. But you could do a table, but, well, it's really not going to do anything for you because, yeah, so you have to know where those ones are. Any questions about any of these graphs? I really do think this is the hardest method, honestly. Or, well, I don't want to say the hardest. It's the most time-consuming method. The next method that we learn is the easiest method, in my opinion. And then we go from there. So, kind of like the middle method. All right, so your problems are going to be 3, 5, 7, 11, 13, 19, and 21.